Okay, so quiz time. You just start this. All right, come to the front, come to the front, come to the front. All right. Okay. You guys go. All right, so you have okay, so 9.5 minutes to go. Okay, anybody still pending? Still doing? How many students who are late still doing? The late students? There are 5 students who are late. Okay, 1 is done. Okay. Okay. How many students still has a script? Any student still has a script? Mr. Tom? Anybody apart from Tom? Okay, nobody. All right, let's start with the lectures. Tom, when you finish, just bring it up here. All right, let's start with the lectures. Okay, that was the easy paper, right? Let me give you the solutions. Let's do the solutions. But Tom, anybody still holding on to the paper? Tom? Done? Anybody else? Okay, then after this I won't accept any more papers. Anybody? Last chance to submit your paper? Anyone? All right, okay, let's do the solution for this. All right, okay. Okay? All right, let's look at this diagram. So you label it on the diagram itself. So let's look at this AND gate. That here is X. This guy here, where does that come from? Q2. So this will be XN Q2, all right? Where does this line come from? X. That line comes from Q1. That will become XN Q1. What will the O become? XN Q2 or XN Q1, right? That's the O. So basically that's your D, right? That's your D1. That will equal to D1. So we can say D1 is equals to XN Q2 or XN Q1. Okay, let's look at the second line. This AND is what? What is this? Q2 bar. What is this here? X. What is this here? That is X and Q2 bar. Well, what is this here? So that there will be X and Q1 or X and Q2 bar. So that's D2, right? So D2 will equal to X and Q1 or X and Q2 bar. Anybody got anything different from D1 and D2? D1, D2, anybody got the same answer as what I've written? All right, very good. Okay. Now, there's one more left. Z. Z, what we call this? Let's see. That will be Q2, yeah? Q2, and what is this one here? The other line? Q1, right? So Z will be what? Q1 and Q2. So Z is equals to Q1 and Q2. That's it. Right? That's it. 3 lines. And all you're doing is basic combinational logic sort of stuff. How many of you were able to score all 3? Okay, all right. Nice, nice. All right. And by the way, I've seen your faces in the lectures. All right. Okay, now, so your table, your state table, you will have something like this. You will have X, right? You'll have Q1, Q2. Then what do you have after that? what will you have? You'll have your flip-flop inputs, yeah? Or, you know, okay, so you'll have D1, D2, you'll have your next state, Q1 star, Q2 star, you'll have your final system output, which is Z. So over here you have system input. Over here you have your current state. Over here you have your flip-flop inputs. I'm writing it in short form. Some people will write it in, this will be your future state. Over here you'll have your system output. So that's what I wanted, your table header, right? Your table header. I don't want you to populate that. That's coming in another quiz, all right? Okay, all right. Now, you have two flip-flops. For question 3, how many states will there be in the state diagram? You have two flip-flops. Therefore, two flip-flops, therefore 2 to the power of 2, 4 possible states. That's it. That's it. Anybody over here scored full marks? Anyone? All right. Okay. All right. So, what we do is, today, up till now, our whole purpose was, okay, the diagram, the circuit diagram was in the note, in the Moodle shell. We went from a circuit diagram, like what we showed you, like in the quiz, right? What we showed you in the quiz, we went from a circuit diagram like what was in the quiz. Then, what was the step? We first found the equations. We found the equations, set, all right? We found the equations. That was fairly easy. Then you do the table. Right, by the way, guys, I forgot to mention, sometimes, if somebody wants, this side here is very important. This side here has to be on this side. The system input and the current state have to be sitting on this side, because we will populate the system accordingly. Because if there's 3 columns, if there's one system input and there's 2, and there are 2, what do you call, current states, how do we determine the current state, guys? We determine it from, how do we determine the number of current states? How many columns in the current state section? You count the number of flip-flops, right? So if there's 2 flip-flops, so there would be 2 current states. This side here is important, because then that gives you a total of 3, so that means there will be 8 possible combinations. This is from yesterday's lecture. Sometimes, some guys would take this and put it here, and take this and put it here. That's fine. That's okay. All right? You can, those 2 sections, you can call it section A, section B, section C, section D. Section B and C you can flip over. All right? Okay. Now, so what have we been doing from now until now? We were looking at a circuit. From that circuit, we were getting the equations like this, right? From the equations, we were getting the state table, right? From the state table, right? What did we have to use? We have to use, what did we have to use, guys? We had to use the tables in order to fully populate this. This part here populated automatically, because if there's 3 columns, so you go 0, 0, 0 all the way till 1, 1, 1. Flip-flop inputs you do using this. Current and future state, well, you get from this table. Flip-flop inputs you get from the equations, right? System output you get from the equation. Then we were able to draw our state diagram. Now, in today's lecture, I want to go the other way around. I want to at least, not all the way, but go from state diagram to the other thing. How many of you have not received a table? Don't have a table? See these guys here? They didn't come to the other lecture. All right. All right. So you would not have received this. Okay, let me just pass this around. Pass this to the guy in the corner. So there's two things. Somebody was here, right? All right. Pass this to the. Yeah. Okay. All right. How many of you have not received this too? Right. Pass it to the back. Pass it to the back. Okay. All right. Now, tables. So we are missing some tables. How many of you have not received a table? Table. Everybody should receive two things: table and something called, what is it called? Some problem number 1 and problem number 2. Just come and collect it from here, guys. A few of them over here. Tables in the front. Okay. So there's tables in the front if you have not collected your table, and there's exercises. Exercises, in-class exercises. Question 1, question 2. Right? Everybody got question 1 and question 2? Okay. Anybody without a table? Everybody with a table, or you don't have a table? Okay. Here, there's one last one over here. Table. So 2 people without tables. All right. Okay, let's see if I find one, then I'll hand it over. See. Anybody without the question, the exercises? Okay, so in today's lecture, I would like to do a design problem. Okay, so in today's lecture, we might not get through the whole lecture, but we'll go as far as possible. And after this, 6 o'clock, or maybe more like 10 past 6, then in my office, I will meet the students who have not collected their paper, all right? So it'll take me 10 minutes to get there. Maybe we can finish the lecture at 6:15, maybe 25 past 6, then we'll, okay, so we are on week 10, lecture 3, today is 2nd June. All right, let's do a design problem. Design. Sequential system design. Again, this is step by step. So don't worry, guys. I've given you some problems. So what I'm going to do is I'm going to do one analysis problem followed by one design problem. Then again, next week, we will do a few analysis problem and design problems. So I'll take it together, right? I'll take it together, right? And you know, I've given you some analysis problems, and we will do design problems now, all right? Okay, so we will take it hand in hand, so that by this weekend, tomorrow, you will see the design problem for your project, and you'll be, okay, I understand what's happening over here, right? Of course, project will be, today's design problem will be easy, because we want to fit it in half an hour. So we want to design a system. Let's do an exercise. We want to design a system where the states change from 3, the number 3 in binary, 3 to, so we don't want to use big numbers, we want to just restrict it to 2 flip-flops. So I'm creating the problem now. We want to design a system which goes from A, state A, to state B, to state C, and then return. So this particular system, maybe let me draw it more neatly. So let's redraw it. Let's redraw that. I'm going to go from A to B to C, and then back to A, right? And then back to A. okay, and we want to say there is a system input, and system input is x. If x is equal to 0, the system goes in this direction. If x is equal to 1, the system goes in opposite direction. Right? System input. Remember, we've been looking at it. So we want to design this system. All right. Now, let us say that A is equal to 3, B is equal to 1, and C is equal to 0. Set? A is equal to 3, B is equal to 1, and C is equal to 0. So therefore, we can redraw this. We can redraw this. We can redraw this as such. 3, 1, 0. Right? What can you tell me in this direction, clockwise direction? What will be the value of x, guys? 0, 0, 0. Set? Okay? Now, by the way, in this system, I want to say that there is, over here, no system output. No system output. So, in our question, the question is this. I've framed the question. There are only 3 possible states. Yesterday's problem, we did 4 possible states. There are only 3 possible states. It goes from state A to state B to state C. Right? Okay, 3 possible states. There is no system output. There is a system input. If it's x, the system rotates in this direction. If x is equal to 0, it rotates clockwise. Right? If system is x is equal to 1, it rotates anti-clockwise. All right. So then what we did is we replaced it with that. Right? How do we accommodate 1? How can we accommodate 1? Well, we say that if it's in opposite direction. We want to look at it at the opposite direction. So let me use another color pen. Let me use red. So if x is equal to 1, it will go in the opposite direction. Can you see that's the state diagram? We will soon expand it further. So these are the numbers. 3, when I say 3, that's as a natural number. We're going to convert that to binary shortly. So let's now once again, let's redraw this. Let's redraw this particular system. So, everyone got that, guys? How I got this here? So we said the question was, this was the question. This was the question over here. That was the question, that we have 3 states A, B, C. A is equal to 3, B is equal to 1, C is equal to 0. There's no system output. In clockwise, it goes A, B, C in that forward direction and return back to A. If x equals 0, it goes clockwise. If x equals 1, it goes anti-clockwise. It goes A, C, B, return to A. A, C, B, C, B, A, C, B, A, C, B, A. And if it's x equals 0, it goes A, B, C, A, B, C, A, B, C. All right? Okay, and it's an infinite loop. All right? So I've drawn that there. Let's now, so I've replaced that. I've converted that to a somewhat like a state diagram. So let's now draw the state diagram. In fact, this is the state diagram. This is the state diagram, guys. This is the state diagram. Okay, now let us draw the state diagram again in binary. So our largest number, what is the largest number on our system? Largest number, what's the largest number in our state? It was 3. Okay, 3, and in binary that will be 1, 1. The largest number is 3, and in binary that will be a 1, 1. Therefore, from the largest number, we can say that 2 bits required, which means 2 flip-flops. Oh, guys, I forgot to mention another thing. I said exercise. I said maybe we build it using build using JK. Build this system using JK flip-flops. So this was the question. So that was in that direction, x equals 0. In this direction, x equals 1. Right? So that was the question. Then I redrew that question to make it like a circle. This here is called a ring counter. It is called a ring counter. All right? Okay, and I'll show you more. Okay. So the largest number is 3. In binary, 3 translates to 1, 1. If you count the number of bits, that's 2 bits. So therefore, 2 bits, that means 2 flip-flops. 2 flip-flops, 2 by JK flip-flop. Okay? All right. Now, let's now draw this. So, let's redraw state diagram. Guys, by the way, I'm just showing you certain things step by step. Just like when I was teaching you combinational logic, I had to show you, oh, divide by 2, remainder 1. But later on, when you get into the flow of things, and you know, when we did Carnot maps, I showed you the cell numbers. But that's the same thing going on over here. I'm just showing you step by step, right? Later on, you don't need to do a lot of these steps. So we want to redraw our particular state diagram. How many states did we have, guys? All right. So what was it? 3. 3 will be 1, 1. Right? The next one was 1. 1 will be 0, 1. The next one was 0, which will be 0, 0. Right? Okay? So we now have that. We have x equals 0. X equals 0. Generally, we just write 0. Right? X equals 0. And in the opposite direction, x equals 1. X equals 1. Sorry, man. I'm supposed to go the other way around. 0, 1. Okay, that will go this way. X equals 1. Sorry. It's supposed to go in that direction. All right, x equals 1. So do you see this here, this state diagram here, is a replica of this, except for everything is in binary now. So what I've done is I've translated into binary. So I can write a little 3 over here, a little 1 over here, and a little 0. Now the way we read it is like this. The 2 bits is, this is QB, and this is QA, right? This is our most significant bit. This is our least significant bit. Okay, but remember, because we've got 2 bits, there's supposed to be 4 possible states. One possible state, when we come to the binary world, then only do we realize if it's a 2-bit system, there is 1 possible state which is missing, because 2 to the power of 2 is 4. There should have been 4 possible states, but we've only worked for 3. So in this particular problem, we have our, what's missing, guys? 1, 1 is there, 0, 1 is there, 0, 0 is there. Which one is missing? 1, 0. Right? 1, 0. So we say 1, 0 is sitting out over here. So we do a forced. So this is an unused state. That guy there is what is called an unused state. So we have a 0 and a 1. Whether if you land at that state by mistake, let's say there's a glitch in the hardware, in software nothing like that happens, but if there's a glitch in the hardware and you land at that particular state, it will be either 0 or 1, input will bring it to one of those states. Okay, so that was the state diagram. That was the state diagram. Okay, let's now draw the state table. Do I have enough space? Okay, I might have enough space. So we can put it all on one page. So let's now look at the state table. Okay, so the state table will start off with, maybe I draw the state table in red. So you have system input, right? You have present state. System input, guys, is what? X. Present state. Let's now label our system as QB and QA, maybe, right? QB, QA. Then we have our flip-flop inputs. And what were we using? Oh, we were using JK, right? So we will have JA, KA, JB, KB. Then we will have future state, which is QB star, QA star. Is there a system output in our case? None. So we are saved from another column. Now I want to show you something. Guys, I want to show you something. When we did the other one, what order did we follow? From the circuit, we went to the equation. From the equation, we went to the state table. From the state table, we went to the state diagram. Yeah? In design, we go the other way around. You have a state diagram, you go backwards. You go to the state table. From the state table, you go to the equations. From the equations, you get to the circuit. From the circuit, then you build in hardware. Right? So in design, is the other way around. So we've got the state diagram. The diagram was in word form, right? And then we got the state diagram. State diagram, we are building the state table now. All right, so let's build the state table. So, guys, I forgot to do the double lines. This here is an important double line, that one there. This is semi-important, okay? But the important one is this one. So I'm going to populate it in black. So can you see there's 3 columns? So how many possible combinations, guys? 8. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, triple 1. All right, now, there we go. So we've populated this. So remember how we built the state table yesterday? We're going to do the backward today. All right? Okay, so come here. So we have a state table. Right. This here is difficult to do. We don't know how to do this. We're going to do this side first. You see, when we were doing the analysis problem, input section, everything fine. No problems. Whether you're doing design or analysis, we've been able to populate this. But when we were doing the analysis problem, we were able to calculate this using formulas. Remember? We were able to use the algebraic equations to populate this. Do you remember yesterday's lecture? Now, in today's thing, in design, this will come first, and then this will come second. So obviously, sorry, this was first anyway, without saying. But the other two in analysis, when we did analysis problem, we do this first, flip-flop input, followed by future state. In design, we do future state first, followed by flip-flop input. Now, how do we find the future state? We find that from the state diagram. We find that from the state diagram. By the way, this particular part, I'll just mention that, you know, maybe if I could have written it, if there is an unused state, direct it to, what is it, A. Direct it to state A. So that is part of the question. I didn't think of this. This is not part of the solution. I mean, it is part of the solution, but it comes from the question. I forgot to mention that in the question. All right, now let's have a look at this, guys. So that's why it's important that you have everything on one page, or everything is visible, so we can follow it up. Okay. All right. So 0, 0. If x is 0 and it's 0, 0, right? See, this is QB, QA, 0, 0. If x is 0, if x is, if the state is 0, 0 and x is 0, where does it go? I'm looking at it from here. Look at this too. If the states are 0, 0 and x is 0, where does the system go? 0, 0. It goes to 1, 1 and x is 0, 1, 1. We're doing the reverse, everything in reverse gear. All right. 0, 1, x is 0. 0, 1, x is 0. Where does it go, guys? 0, 1, x is 0. It goes, becomes 0, 0. Yeah? All right. 1, 0, x is 0. 1, 0, 1, 0, 1, 0. Not here, it's over here. 1, 0. Whether it was a 0 or a 1, let me zoom out. Okay? Whether it was 0 or 1, it will come to 1, 1. 1, 1, x is 0. 1, 1, x is 0. 1, 1, x is 0. It comes this way. Becomes 0, 1. Let's look at this. 1, 1, sorry. Next one. 0, 0, x is 1. 0, 0, x is 1. Will become 0, 1. 0, 1, x is 1. 0, 1, x is 1. It will become 1, 1. 1, 0, x is 1. 1, 0, x is 1. Where? Okay, yes. 1, 0, x is 1 comes here. All right. Okay. 1, 1, x is 1. It becomes 1, 1, x is 1, becomes 0, 0. There we go. Done. State table, one section filled. Last section to go. Now, you pull out, at this point in time, you pull out your magic tables. All right. You pull out the table. Let's see. Right? If your neighbor, I hope everyone's got one, but I know 1 or 2 students. Let's see if I can find any over here. Last. Lucky last, lucky last, lucky last. All right. No. Okay. Yeah. Radio. Can't find anything. Right. Nah, sorry. Okay, anyway. Now, look at the scenario. Look at the scenario. Our scenario is such. We have the current state. We have the present state. We have the present state. We have the future state. What table do we use? Yeah, okay, it's JK. We know it's going to be in the JK area. We're not going to use D or T, right? Okay? You have the present state. You have the future state. Which table? Characteristic table, excitation table, or truth table, or analysis table? Which one? Excitation. If you have current and you have the present, if you have the present and you have the future, you want to look at the excitation table. All right, so let's go to the JK excitation table. Here it is, this one. JK excitation table. Really simple table. If you look at it, it's a really simple table. All right. Okay, so JK excitation table. All right. We have QB0, so come here, let's come here. Let's not worry too much about X right now. QB0, QB star 1. 0 becomes 1. What should be our J and KB be? Right? Remember, we're dealing with B, all right? We're dealing with B. And unfortunately, what I did is I wrote everything in, maybe it's good time to change it now before we, let's convert that to B so that it becomes easier to read, all right? Right, okay. Right, so I've written it in that same order. So just correct that. I've written B first. It doesn't matter. You can put A as well. It doesn't matter so long as you get it, right? So long as you don't confuse yourself. This is, okay, 0, KB, QB becomes QB star, right? Look at the board. QB becomes QB star. 0 becomes 1. Go to the table. If 0 becomes 1, what should our J and K be? 1 and X. All right. 0 becomes 0 will be 0x. There's only two possibilities. 1 becomes 1. 1 becomes 1 will be XX. All right. 1 becomes 0.